Thank you, Dr. Bishir, for this very interesting introduction. Can you see my screen now?
Yes, Dr. Ali, we see it.
Very good. So welcome to this training. Actually, this training, Watering the NDCs, I will directly enter into the contents. We have 5 modules. We will present these 5 modules in 5 days, 2 hours each day. So in this week, we will have module 1, introduction, which is for today, introduction to water and climate change. And then tomorrow, we'll have the module 2 about current status of water in the NDCs. Module 3, it will be Wednesday, this week also, enhancing water in NDCs. And Thursday, we will give the module 4, the nexus approach to enhance NDCs. Finally, the last model will be for the next week, next Monday, and it will be about governance, climate finance, and technological innovation for actions in NDCs. So I hope that you will enjoy and you will benefit from this training activity. Let us start firstly with the first module, which is the module of today, Introduction to Water and Climate Change. The outline of the module of today, we will have actually about 8 sections. In the section 1, we will introduce the climate change, a quick introduction, just to know. Then we will look into the climate change and water interactions in section 2. Section 3, we will talk about the broad impacts of climate change on the Arab region. And then we'll talk a little bit about the vulnerability to climate change and also the international policy frameworks in section 5. And section 6 will give some insights about the cross-sectoral challenges and the need for integrated assessments. And in section 7, we'll take a small exercise about how to calculate the energy from wastewater, anaerobic wastewater treatment, which is important to climate change adaptation and mitigation. And it's also related to water. We'll talk about this exercise on time. And in section 8, we have a quiz. So be careful, huh? We have we will take a quiz, a rapid quiz of 10 questions, multiple choice. Actually, don't afraid, it's not graded. So it's just to make like a revision of what we said in this training. We'll take it online with Zoom. So you will have this quiz directly on your screens. And finally, we will give some group discussions. So this is the outline of the module 1 for today. Let's start with the introduction to climate change. As we know that the Earth's surface absorbs the solar energy that heats it. So we'll try to figure out how this climate is impacting, affecting our Earth's surface. So the Earth's surface absorbs the solar energy that heats it and converted into heat, causing infrared radiation to be emitted into the atmosphere. Let me take my pointer. So this is the infrared radiation emitted again to the atmosphere. Some of the infrared radiation is re-emitted back to Earth, and this is the effect of the greenhouse gas molecules. The greenhouse is surrounding gas molecules is surrounding the atmosphere. Now, if you want to look a little bit about the extent of the emission, just to have an idea or quantitative idea, how much we are really emitting and how much, for example, in 1 million molecules in air, it contains, I will just concentrate on greenhouse gases, it contains 3,900 H2O molecule, water molecule. It contains also 280 molecules of CO2 and 1 molecule of CH4, methane. So as you can see, 1 million molecule of air, it contains these quantities of greenhouse gases. Now look what we did during this 250 years. What are the additionals? For the water molecule, we can notice that it's 210 additional. For the CO2 molecules, we can notice that it's 110. Out of what? 280 originally. So the additional, the amount of the additional is around 40%. which is a huge now, which is a huge variation in the CO2. And of course, for the methane also, it was 1 molecule in 1 million. Now look to the number. It's the additional is also a 1 molecule, so it's doubled, 100% additional of methane gas. So as you can see, that the 4,200 molecules, greenhouse gases molecules, are able to increase the planet temperature by 33 degrees Celsius. Then we must take serious note of the fact that we have added 33 molecules in the last 250 years to the atmosphere. It's a sizable fraction of emissions. Since we are talking about emissions, for example, let's take, for example, an overview now, the emissions by countries and region. For example, in China now, they emitted around 27% of the global carbon emission budget, which is the largest now. And then after that, we have United States, European Union, India, Russia, Japan, and the rest of the world around 43%. So my question to you, what about the Arab region contribution in greenhouse gas emission? Do you know? Anybody knows?
I
think it's about 5%.
Yes, exactly, 5%. Thank you. Very good answer. So it's around 5%. Actually, if you need to go to see the global budget, you can reach this site mentioned here. So this will be in your presentation, in your documents. You can go and see global greenhouse gas emissions, and also you can see by country. So you can find your country and see what are the emissions from your country. Okay, very good. Now, what will happen now? Actually, these emissions or this variation of greenhouse gases has increased rapidly the temperature of the Earth. And we are all noticing this all around the world, and particularly in our region. I can tell you that in Lebanon, we feel the heat each year. It's really, actually, the temperature is higher than the average. We feel that very, very clearly. So the temperature is rising, and this is obvious. It's clear, no doubt about that. Now, if you want to talk a little bit rapidly about the climate system and the climate models, and you know that there's climate models that forecast the climate in terms of temperature and precipitation and variation in precipitation. What I want to say that the climate, as I said, it's a very complex system. So you have to be careful that any modeling of a complex system such as the climate and in prediction for many years in the future, there is lots of uncertainty. Let's be clear on that. So don't take the predictions, particularly in precipitation and variation of water availability. This would be really include a large amount of uncertainty. Now, if I want to say that warming of the climate system is uncontestable, okay, we have to admit that. However, regarding, as I said, there's a greater variability of precipitation, and there is a more extreme phenomenon. The climate models give these results. But as I said, we have to take it in little bit of precaution, particularly with regard to the uncertainty of these results. Now, there is so much focus on limiting global temperature rise to 1.5 degrees. Why this is very important? Because actually there is a lot of risk. This is a trigger degree, a trigger level that will actually make a lot of risk. To understand that, I will, if you permit me, I will show a video, a very short video, talking about this trigger point, the 1.5, and what are the impacts globally. So let me stop sharing now.
These are the 16 tipping elements, the large biophysical systems that we have scientific evidence that they regulates the state of the entire climate system on Earth. 9 of these 16 are showing signs of instability. Push them too far, and they will shift over from supporting humanity to starting to undermine humanity. 4 of these are showing scientific evidence of now being at risk already at 1.5 degrees Celsius. We're approaching this point very rapidly. 2 of them, the Greenland ice sheet and the West Antarctic ice sheet, together represent 10 meters sea level rise. This shows scientifically that 1.5 degrees Celsius is a physical limit. It is not a political target. But what I say next will be the most alarming thing. We have more and more scientific evidence of connectivity between these tipping elements. Cascade risk of dominoes. Let me give you one example. Here's the one that is most researched. Greenland ice sheet, accelerated melting, warming 4 times faster than the planet as a whole, releasing cold fresh water, slowing down the overturning of heat in the North Atlantic, pushing the whole monsoon system down further south, causing droughts and forest fires over the Amazon rainforest, one more tipping element system, locking warm surface water in the Southern Ocean, accelerating the melting of the West Antarctic ice sheet. The North Pole is connected to the South Pole in regulating the stability of the entire Earth system. Dear friends, scientifically, this is not a climate crisis. We are now facing something deeper. Mass extinction, air pollution, undermining ecosystem functions, really putting humanity's future at risk. This is a planetary crisis.
Okay, so we see that in this video, the alarming notice to humanity that be careful, the 1.5 degree is very critical to the climate and the impact of also on the humanity at all. Now, let's back to the COP27, Sharm el-Sheikh, Egypt, 2022. I think most of you have follow up on this climate event in our region. So I would like to ask you a very short question or small question about what are the significant milestones resulted from COP27 climate summit. Do you know, do you have any idea about the milestones that results from this COP? Actually, there's 2 important milestones.
The creation of the damage fund.
The creation
for developing countries.
Yes. Exactly. Very good. Thank you. Okay.
Thank you.
Actually,
and the activation of Santiago network.
Yes, very good. Now, but actually, help vulnerable countries deal with losses and damages was really, from the impacts of climate change, was really the most, let's say, significant milestone. Also, in addition to putting water and food in the center stage. Now, let's move to the section 2. Okay, so in section 2, we will talk a little bit about climate change and water. Actually, global water use, as you can see here, in all sectors or all water uses activities, we noticed that the water has increased by a factor of 6. Imagine, a factor of 6 during the past 100 years, and continues to grow steadily at a rate of about 1% per year, which is very, very high increasing rate. And also this because the increasing population, economic development, and shifting consumption patterns. So if we want to look to the Earth climate and Earth water cycle, and we know all what I mean by water cycle, we found that there's a very close and complex relationship. Okay, we admit that. So now, taking into consideration this close relationship, we want to little bit find out what are the impacts of climate change on water. If we want to study or analyze these impacts or identify these impacts, we have to look from 2 sides. Okay, we have to look from the supply side of water, and also we have to look from the demand side. Okay, let's start firstly from the supply side. I would like from you to give me some actually some impacts, how climate change could impact the water in the supply side state. Okay, I will take your answers if you don't mind.
Reducing in precipitation.
Yes, Mahmoud, very good.
I am Mahmoud Sibai. I am from the National Committee of Syria. I am the Dean of the Higher Institute for Water Resources in Syria.
Thank you, Mahmoud. Did we met before, Mahmoud?
I think so. I'll put I'll open my video, so hopefully you can recognize me.
No, because actually the name. Yes, of course. Yeah, you work on
Yep,
ModFlow very well, huh?
Yep. That's true.
You are the master of ModFlow.
Thank you, sir. Thank you.
Yes, we met before, Mahmoud. Thank you, and very glad to have you here in this training. Yes, you are right.
Thank you.
Your comments are valid. Can we have other?
Yes.
Go ahead.
Can I? Hello?
Yes, Nahid, go ahead. We are hearing you, Nahid. No problem. We are waiting for you. I think Nahid, she has a problem maybe on the internet connection. So we will.
Okay, may I say something? My name is Yasmin Al-Lawati. I'm from Oman and I'm representing the Oman Water Society. I'm specialized in, oil produced water, but I'd like to learn more. We're currently working on effect of climate change on Oman weather because we're having flash floods that are coming. So I think we also are having a lot of fresh water from this rain coming. And it's going straight to the sea because we are losing it and it's difficult to capture it. And I don't know how. So I mean, you're saying that it reduces the amount of water, but also it increases the amount of water, right? So am I wrong?
Yes, it depends on the variation and the projection of variation. Yeah, in some regions it increase, in other regions it reduce. Of course, in terms of precipitation, the frequency is changing, and on the intensity of rain is changing. It causes flooding, actually. Thank you, Yasmin, for your contribution, and we are very glad to have you with us. Anybody want to add something?
Yes, I'm Sia Mereshi. I'm from Morocco, from the General Directorate of Water. I'm working on hydroclimatic monitoring service. And yeah, for me, there are many impacts on climate change on water. You said the increasing of extreme phenomena. It could be drought or it could be floods, but also the increase of temperature has a direct impact on water. So maybe we can have some waters stocked in the reservoirs, and with the high temperature we would have more evaporation and more evapotranspiration from the ground and from the field. So it's can have a direct impact on production, agriculture production, and yeah, we can.
Thank you.
Issues like that.
First of all, welcome, Shiham, with us, and thank you for the answer. It's a very good answer, actually. Evaporation from reservoirs and due to increase in temperature. Thank you, Shiham, for your contribution.
Thank you, Doctor.
Okay, so let's move. Yes, Amjad.
Yes, Doctor, I am Amjad Salah from Ministry of Water Resources and Irrigation of Egypt. Also, I think the rainfall distribution will be varied due to the high range of temperature in different regions.
Yes, thank you, Amjad. Yeah, of course. Okay, so let me stop taking your contribution now. I will back to my presentation. Okay, so can you see my presentation again?
Yes.
Thank you for the answers. Actually, all the answers were valid and correct. Now I will introduce you a little bit about these impacts. Firstly, the change in precipitation patterns. So climate change is expected to alter precipitation patterns, with some regions experience more frequent and intense rainfall events, while the others may experience longer periods of drought. So this can impact water supply for both surface water and groundwater. The second impact related to change in snow melt patterns, and this is for countries that have snow in the Arab region, like Lebanon, for example. So changes in temperature and precipitation patterns can also affect the snow melt patterns, which can impact water supply for downstream users, particularly in mountainous region. We can also mention the increased evapotranspiration rates, as Siham mentioned. So as temperature rise, evapotranspiration rates are expected to increase, leading to a decrease in water availability for both surface water and groundwater. We should not also forget the change in water quality. Climate change can also impact water quality with changes in temperature and precipitation pattern, leading to change in water chemistry, including increased nutrient loading and salinization. So let's move now to the impacts of climate change on demand side. Okay, so we take some impacts from the supply side. Let's move now to the demand side. So the same thing, I would like to take your contribution on that to see if you have any idea, and then we will back to the presentation. So anybody want to contribute to the impacts of climate change on the demand side?
Okay. Okay.
Nahid?
Hello.
Yes, Nahid, we are hearing you. Just present yourself and go ahead.
Okay. I'm Nahid Abdul from Sudan. I work for the Ministry of Irrigation and Water Resource, the Groundwater Basin General Directorate, Groundwater Basin Section.
Welcome, Nahid.
Thank you very much. I'm very glad to be here with you.
Thank you.
As we know, the climate change is interchangeable. It is a drought and severe drought or severe flood. On demand side.
Sorry.
Sorry.
Siham, please mute yourself. Okay, I muted you. So go ahead, Nahid. Yes.
Okay. From the demand side, I think the effect of drought is much more.
Yes.
Because there is increased demand for domestic use or for industries or for whatever, and there is a shortage of water. So this will be very severe, and also this will impact the food, with impact and the agriculture, has impact on agriculture, or even in the forest.
Yes.
So the demand will increase.
Very good, Nahid.
Due to the impact of climate change. Okay, thank you.
Thank you, Nahid. Very good. Very good answer for this question. Yes. Anybody want to contribute? Alaikum salam, Asma. Yes, go ahead.
Alhamdulillah. أسمع رجالي سوية حاليا المعرض خاص بالزراعة الرقمية، وأنا مشاركين باسم المركز الوطني للأرصاد الجوية بخصوص المعلومات على قسم الأرصاد الزراعية. مشاركين به ومشاركين بالمركز الوطني للأرصاد الجوية.
Okay, Asma, thank you for your presentation. Do you have an answer for our question about the impacts on water, on the demand side of water?
مرحب بحضرتك وبجميع الحضور.
Okay, thank you, Asma. Actually, we have difficulties of hearing you. Maybe it's the internet connection. Thank you for your contribution. Back to the presentation. Can you see my screen now? Right? From the demand side, we are talking about firstly increased demand for irrigation. Okay, as temperatures rise, the demand for irrigation water for crops is expected to increase. So also as evapotranspiration rates increase and soil moisture level decrease. So this is the first impact. Also increased demand for cooling water. As temperatures rise, the demand for cooling water for thermal power plants and other industrial activity is also expected to increase. We are talking about increased demand for domestic water. Higher temperature and changing precipitation patterns can lead to increased demand for domestic water also, as people use more water for drinking, cooking, and hygiene. Increased demand for water for ecosystem services. So climate change can also impact natural ecosystems, leading to increased demand for water to support ecosystem services such as wildlife, habitat, and recreation and tourism. So those are, let's say, some of the impacts, as we mentioned, from the demand side and supply side. Now, how to address these impacts on water supply and demand? So, actually, we will this title or this subject will be tackled or addressed in the next module. Okay, so don't worry about answering this question. We will actually talk about this lot in the upcoming modules. Now, basically, if we want to go to climate models that give some predictions, so we can see some, let's say in our region, we can see that there's a decrease in precipitation on water availability. Personally, as I told you, that you have to be careful when taking results from climate models about the water availability and precipitation. You have to keep in mind the uncertainty. Because it's difficult really to predict a long period of time using the climate models. Here I would like to show you that there is some regional and global initiatives that you can take some, let's say, predictions on the climate in the Arab region. Regionally, we have RICAR, developed by ESCWA. I put here the websites links, so you can go and check up. Also, we have globally, we have the Couplet Model Intercomparison Project from the World Bank. The IPCC actually also has developed a website to present some possible climate futures in terms of precipitation and temperature. Very good. Let's move now to the section 3, broad impacts of climate change on the Arab region. Firstly, let's look to the economic impacts. Let's take the economic point of view, how climate change would impact the economies in our region. Clearly, because we are a water scarcity region, this will have critical impacts in our region. And as you can see, we are actually, the variation in GDP, we are in minus. Now, if I want to give some of the potential economic impacts, particularly in our region, which is a water scarcity region. So we can think about agricultural productivity. Agriculture is a significant source of employment and economic activity in the Arab region. So actually, but it's also one of the largest users of water. You know that in the Arab region, the percentage of water used in agriculture sector is around 80%, far away from the global average. Do you know what the global average is? 70%. So now you know that we are the agriculture sector in our region is a huge consumer of water. So climate change induced water scarcity is expected to decrease the crop yields and reduce agricultural productivity, leading to lower agricultural incomes and higher food prices. Also, if we think in the industrial production, the Arab region has a significant manufacturing sector, particularly in energy-intensive industries such as cement, steel, and petrochemicals. So these industries require large amount of water, and climate change induced water scarcity could lead to higher cost of water and energy and reducing their competitiveness and profitability. We could think about the tourism also. So we have lots of tourism in the region. So actually, and this would also, the climate change can impact, such as like the sea level rise increase, and also the heat waves. All these impacts will have effects on tourism. Human health, one of the issue that we can also mention. Climate change induced water scarcity could lead to increased waterborne diseases, particularly in urban areas where water and sanitation infrastructure may be inadequate. This could lead to increased healthcare costs and lost productivity due to illness. Water infrastructure also could be impacted by the climate change. As overall, we can say that the economic impacts of climate change in the Arab region are expected to be significant and varied. Effective adaptation and mitigation measures will be essential to minimize these impacts and ensure sustainable economic development in the region. Okay, fine. Let's go to the section 4, vulnerability to climate change. Everybody knows what's the meaning of vulnerability. But if I want to take the vulnerability assessment methodology developed by the IPCC fourth assessment report, the methodology of IPCC is based on evaluating 3 variables or indicators. The exposure, the first one, I will take my pointer again. Exposure, this is the first variable or index or indicator. The second one is the sensitivity. From these 2 indicators, we can compute the impact of the climate change. And from the impact and adaptive capacity, we can evaluate the vulnerability index. So let me give you some definitions. Okay, firstly, the exposure. It's the change in climate parameters that might affect socio-ecologic systems, either directly or through, for example, disrupting the flow of goods, finance, information, or people in an area. The sensitivity, by definition, the state of the physical and natural environment that makes the affected system particularly vulnerable to climate change, okay? Including population density, migrant and refugee population, and urban extent. The impacts, which are the results of exposure and sensitivity. Is determined by combining the exposure and sensitivity to climate change on a system. The adaptive capacity, the last one, the ability of a system to adjust to climate change, categorized as knowledge and awareness, institutional capacities, infrastructure, economic, including food imports, and technological resources. So these are the definitions. Let's see how to compute or how to evaluate the vulnerability in a small example, rapid example, just to put these definitions and these concepts into practice. Let's say, for example, in this example, we are assessing the vulnerability of a coastal community to sea level rise. Okay, so we will think about what types of variables we want to take for exposure. We can think that the percentage of population living within 1 kilometer of the coast is one of the variables. So this is one of the variables for exposure. The value of this variable is 60%. Now, in our example, okay, we'll take 60% for this variable as a value in this example. Now, if you want to move to the sensitivity, so actually the sensitivity is the degree to which the community is likely to be affected by the sea level rise. So think about the variables. We can take, for example, a variable about the percentage of population over the age of 65. This variable could be respond to this sensitivity of the level of the sea level rise. Also, we can think about the percentage of households below the poverty line. This is another variable. By the way, I'm presenting some variables, but you can, when you take a real case or when you're working on your case study, it's much more than that. You can put many other variables related to each one of these parameters. The adaptive capacity, let's say, for example, we can think about number of emergency available in the event of a flood. We can think, for example, about the percentage of population with flood insurance. If I want to calculate the vulnerability now, taking into consideration all the variables that I presented to you, I can use the method or the equation of IPCC that I mentioned. The vulnerability is an indicator or an index. Using the weighted average, I can calculate the vulnerability by multiplying the exposure and sensitivity and dividing to the adaptive capacity. This is the formula used by IPCC. Okay.
دكتور علي، قبل البدء بسكشن 5 تسمح لي بس احط one single slide.
Yeah, go ahead, Dr. Bashir. Yes.
للإجابة على تساؤلات فقط. أنا بلاحظ دائما إنه يكون عندنا تساؤل كلياتنا إنه كيف بيكون الكلايمت تشينج بيزيد المي وبينقص بيقلل من المي، بيزيد الأمطار وبيقلل من الأمطار. فهذا السؤال طبعا في كثير له علاقة بالغلاف الجوي، إمكانية الغلاف الجوي إنه يتحمل كميات أكبر من بخار الماء بسبب ارتفاع الحرارة. حتى ما في داعي تحط سلايد، أنا ممكن أبعته لحضرتك وأنت إذا بتحب تحطه ضمن المواد، بس إذا ما عندكم مانع ما عندي مشكلة إني أحطه للسلايد.
لا، go ahead بشر. Yes, you are co-host.
شكرا جزيلا، شكرا جزيلا دكتور. من بعد إذنك إذا تسمح لي to share my screen.
Yes.
Okay, I'm going to share the screen right now. Okay, واضحة الشاشة عند الأخوات والأخوات؟
Yeah, it's clear for me.
إذا
Yes.
اوكي، شكرا جزيلا. طبعا المرحله الاولى طبعا زياده غازات الاحتباس الحراري في النقطه 0 كما كلنا شايفين حتاثر على ارتفاع درجه الحراره، وهذا الشيء الاساسي او المقياس الاول اللي بنعتمد فيه على انه هناك تغير في المناخ climate change. بارتفاع درجه الحراره طبعا مثل ما بنعرف كمان مثل ما تحدثت احدى الاخوات انه بتزيد كميه الايفابوريشن من الأسطح المائية، إضافة طبعا لزيادة الإيفابوترانسبيريشن من التربة ومن النباتات. ولكن في كل الأحوال أهم شيء في الموضوع أنه عندما ترتفع درجة حرارة الغلاف الجوي حتى ولو بدرجة أو درجة ونص، حيكون إمكانية الغلاف الجوي لأنه يحمل كمية أكبر من بخار الماء ومن أي غاز آخر من حيث الضغط الجزئي، هتكون إمكانية الغلاف الجوي ليحمل كمية أكبر من المياه في حالة بخر قبل ما يصير كوندنسيشن ترتفع الحالة. فعندك في الحالة هي ما يسمى بالريزيدنس تايم، الفترة التي تقضي فيها البخار الماء، الزمن الذي يمضيه بخار الماء في الغلاف الجوي قبل أن يتحول إلى أمطار تزداد، أو بما يعني وتزداد. فعندك زياده في قضيتين، عندك زياده في الاتموسفيريك مويستشر بحد ذاتها كميه البخار المياه الموجود في الغلاف الجوي، وزياده ايضا في الوقت الذي يمضيه هذا الماء في الغلاف الجوي دون ان يتحول الى امطار. لما بيحصل مطر اول شيء زياده الوقت هي اللي بتسبب الجفاف، لانه ما بين العاصفتين المطريتين او ما بين الامطار وخاصة الأمطار القليلة وليست العواصف الكبيرة، هي تقريبا حيكون في فترات طويلة جدا بينها، وهذا بيؤدي إلى جفاف خاصة في المواسم المهمة. ولكن باعتبار أنه في كمية كبيرة من البخار موجودة حاليا في الغلاف الجوي، عندما تحصل الأمطار وبصير كوندنسيشن تحصل بشكل عواصف شديدة. فهذا اللي بنقوله إنه التغير المناخي بسبب هالظاهرة، طبعا هي ظواهر معقده اكثر بكثير ولكن هذا ابسط شكل لاشكال الظواهر هي. التغير المناخي بيؤدي بذات الوقت، يمكن ان يؤدي بذات الوقت الى زياده الجفاف، ولكن عندما تحصل الامطار تحصل او العواصف الكبيره تحصل بشكل غزير جدا وتؤدي الى فيضانات. واعتقد كلياتنا وخاصه في منطقه الجزيره العربيه عم نلاحظ هناك تغير في الباترن بتاع الامطار، بيكون في امطار اقل ولكن عدد الايام الماطره ممكن يقل، ولكن عندما تحصل امطار عم تكون امطار بغزاره اشد مما كنا نلحظها سابقا. هل البروسيس واضح حاليا؟ انا اعتقد اخواتنا واخوتنا اللي بيشتغلوا في الارصاد الجويه اكيد عندهم شرح افضل بكثير من الشرح المبسط جدا هذا، ولكن هذا الشرح يوضح انه شو الميكانيزم اللي بيسبب انه في ذات الوقت يحصل عندك زياده الجفاف وزياده في الفيضانات. فيضانات الفلاش فلود بالذات بحد ذاتها. شكرا كثير دكتور علي على اعطائي الفرصه.
شكرا دكتور بشر. بس في عندك سؤال من دكتور معن اي ثينك.
تفضل دكتور معن.
دكتور
انا
معن.
مش سامع دكتور معن.
ايه لحظه بس لنشوف. دكتور معن you raised your hand. You want to ask? دكتور معن داوود. Okay, maybe it's not.
على كل الاحوال انا راح ارسلكم السلايد دكتور علي، شوفوا كيف بتحبوا. اذا ارتأيتم انه من المناسب وضع ضمن المواد على ما توسع.
طبعا.
الو
ايه دكتور معن.
تفضل دكتور.
ايه عفوا. هلا دكتور بشر، دكتور علي، شكرا لاتاحه انه احكي الان. القضيه مثل ما انشرحت هلا من شوي، ولكن مع بعض الاضافه. يعني انا
تفضل دكتور.
حاطط حاطط انه الامثله نحن غير الحساسيه المرتبطه بالمجتمعات الساحليه المرتبطه بارتفاع مستوى البحر. نحن هذا المثال هو للدول الجزر، ولكن المثال الاشد واللي هو اقصى بالنسبه للدول العربيه هي قضيه انه رغم عدم الانخفاض الكبير في كميات الهطل المطري الوسطي لفتره طويله الامد، ولكن بيصير في عندي حساسيه للتغيرات الشديده للظواهر المناخيه المتطرفه، رياح عاتيه، امطار عاصفه مفاجئه، وشدات مطريه غير ملحوظه سابقا، مع حركات دورانيه. هذا بيؤدي من ناحيه اخرى ضمن تغيرات المناخ العالمي او القضايا المرتبطه بفيزياء المناخ، بيؤدي لحساسيه مرعبه في انتاجيه المجتمعات النباتيه وتغير في اطوارها الفينولوجيه، وهذا الشيء اكثر حساسيه بالنسبه لنا بالدول العربيه بتصور. شكرا.
دكتور في سؤال بسيط هون. دكتور هذا كمان بتعتقد انه ممكن ياثر كثير على المناطق الهامشيه زي الباديه مثلا، يكون تاثيره اكبر؟ يعني ممكن نشوف زياده التصحر وايضا وجود نباتات يسموها نباتات الغازيه، هذا ممكن ياثر كثير كمان. ممكن هذا يكون احد الاثار دكتور على الامن الغذائي؟
نعم شكرا دكتور بشر اكيد، شكرا للدكتور معن. بس انا حابب الدكتور معن لو سمحت ممكن تعرفنا بحالك اكثر بس لحتى نعرف باي بلد واي جهه.
أنا معن داوود، أنا بشتغل بالهيئة العامة للبحوث العلمية الزراعية، باحث رئيسي، عضو IHB بسوريا. أنا من سوريا وعضو أكاديمية علوم روسية.
Thank you Dr. Mann. Yes, your comment.
اختصاصي بإدارة الموارد المائية وتخطيط الاقتصاد الوطني المائي.
Very good. Okay.
دكتور علي تسمح تشيل من الشيرنج سكرين. It's yours now.
I can stop you sharing.
Yes, thank you, sir. Thank you. Now I have it. I can see it now.
Okay. So thank you, Dr. Bishop, for your contribution. It was really interesting. And thank you also for Dr. Mann for the comments. Of course, what Dr. Mann said is valid. The example that we presented is very simple, actually just to show you some numbers and to make to try to put the equation and to show you that. So of course, in our region, in the Arab region, and it's not only, we cannot talk here regionally only, we can talk also locally by countries. And even in each country, you have local conditions, not only country-wise, but also sometimes watersheds or cities or whatever. So all these are local specific, and we have to take all these into consideration. Very good. Let me continue with my presentation. I will share my screen again. we are now reached the section 5, international policy frameworks. Of course, we are talking about the nationally determined contribution, the NDCs, and this refers directly to the Paris Agreement. Of course, the decision of the Paris Agreement that Paris parties to undertake and communicate their post-2020 efforts in the form of NDCs, and to communicate their first NDCs no later than the party formally joins the Paris Agreement. What I want to do is, please put a folder in your computer, a folder for the training, and particularly for the training, and we will put all the documents that we downloaded from the global sites, websites, and put it into your folder, because all these will be a country reports for your country. So you will have all the reports that we will talk about it in this presentation. So let me bring the website of the NDCs to download the NDCs. Just 1 minute. So firstly, I would like to share with you where to find the NDCs of your countries. Okay, I will put it in the chat. Okay, before presenting on my computer. Okay, can you see my screen now? This is the website that I want to show you, where you find the NDCs of the countries. Can you see it? Okay.
Yes.
Very good.
Yes, doctor. Yes.
Yes. Find your country here in this table, and you can download it. So you would have, in this case, you can have the NDC report of your country in your laptop. Fine. This is important to us for the next sessions. The National Adaptation Plans, also it's a process that was established under the CONCOM adaptation framework. This types of reporting enable countries or parties to formulate and implement national adaptation plans as a means of identifying medium and long-term adaptation needs. I will give you the website again on chat. Okay. This is the website where you can find your report. Okay, so this is the website of NAPS. As you can see here, you have all the countries. We can find, for example, from the Arab region, the first one, we have Sudan submitted. The biennial update reports, BUR, are actually reports to be submitted by non-annexed one party, containing updates of national greenhouse gas inventories. So as you can see that the BURs are really for the greenhouse gas inventories, which are important for mitigation actions also. Okay, so can you see the screen now?
Yes.
So actually, look to this report. You can find, for example, in the scrolling down, we can find that Algeria did not submit any BUR report. If we go downward, we can find also Bahrain not submitted. We can go forward and we can find, let's say, the national communication also is another type of reporting. The national communication, this is for non-annexed one parties that required to submit their national communication within 3 years of entering the convention, the UNFCCC convention. So here the link to show or to download your national communication report. Generally, the national communication actually contains a national inventory of greenhouse gas emissions, like the BUR. Also, it contains measures to mitigate climate change. Also, it assesses the vulnerability and adaptation to climate change and put some financial and technical and capacity building supports and gaps. It's also good to have an idea about your country, how they are reporting on land degradation neutrality target setting program. And these reports are available here. Okay, I will give you the link so you can download your report, your country report. National drought plans. The national drought plans also existing, and you can download also your reports relating to the national drought plans, which also related to climate change. As you can see, there's many reports that relates to climate change that are published globally. So we have to download all these reports for your country to see what are the connections between all these reports, what are the actions taken, if these actions are coordinated or not. All these issues will be discussed in the next modules. You can also download the voluntary national reviews for the SDGs, which is also available at this web with this link. I will share you the link with you. Okay. Actually, we found that when we look to all these reports in majority of Arab countries, we found many reports that are dealing with actions related to climate change. We noticed that there is a weak coordination in planning and management, and this is a gap, and we want to make sure that all these actions are coordinated. So water really, as everybody said, that water is a connecting. Say that water, we can say now that water is a connector, okay, among many. We arrived now to the exercise, okay. This is the last section before the quizzes. So I will share again my screen to see what type of exercise you want to take.
Yes, Dr. Ali, number 7 exercise.
Yes, yes, Dr. Yes.
Very good. Look, what we want to do now, actually, it's an exercise to compute the energy that could be generated from wastewater. Okay, we want to take a quantitative exercise on that. And as you know, that wastewater can generate energy. We can recover energy from wastewater treatment. And so we will show how to make the calculation. But before that, I would like to explain to you why we are doing this. Okay, so the reasons for that is when you look to the IPCC guidelines for national greenhouse gas emissions inventories, the equations that compute the greenhouse gas emissions, particularly for the methane gas, as it shows. I will take my pointer just to. This is the equation. And by the way, we will take another exercise on computing emissions based on these guidelines, based on the IPCC guidelines. This I think will be the next module tomorrow. But now, just I want to show you why we are actually making an exercise of calculating the methane gas produced from wastewater and use it in energy production. Look to the equation of emissions. You can find that these factors calculate the emission, the CH4 emission from wastewater, and you can find here minus R. R actually, what R? It's a factor. We have the given. We are talking about wastewater treatment plants that cover a population of 1 million persons. To get the answer, we can start by calculating the biological sludge production. The biological sludge production is I take the dry matters that result from one person multiplied by the number of persons. I can get the total value of kilogram of dry matter per year. Then I took the organic matter that exists in these dry matter by multiplying by 0.8. Then I have the kilogram, the weight of organic matter. Now I want to transform this organic matter into biogas. I'm using, let's say, an anaerobic treatment with an efficiency of 0.5. So actually, I'm destruction of this amount of organic matter. This amount will give me a biogas production by multiplying the 0.9 I can get the volume of biogas in meter cube per year. And this biogas, it is in the primary setting. I can calculate the calorific value by multiplying by 6.4, which give me the kilowatt hour per year in pounds. And this is a primary setting. Now, if I want to produce electricity from this biogas, I have to go into the 0.39, which is the electrical production efficiency. And I can get actually this amount of electricity, which is around 26.9, yani 27 gigawatt hour per year. Okay, and we know that heat released is around 29 gigawatt hour per year. So as you can see, this rapid example, I showed you how to calculate the electricity that you can generate from wastewater treatment. At the same time, it's an adaptation measure or action, but also it's a mitigation action because we are producing methane from the wastewater and use it in electrical production. We arrived to the quiz. So be ready. I want to share now a quiz. Can I stop the pause now?
I need an additional time, please.
Okay, I will give you another 2 or 3 minutes.
Thank you.
Very good. Actually, we have a large amount of correct answers. This is good. The percentage is above 70% usually in all the questions, which is good results. So with this, we end this module for today. I would like to thank you all for your participation and for your contribution also. We had a very good contribution from everybody.
Dr. Ali, can I just ask a question?
Thank you.
We have approximately